Paul Park is from Soil and Water Solutions, and he's asked me to deliver his talk today because he couldn't make it. Paul and I both formerly worked with the Soil Conservation Service. So Paul based in Newcastle, Maitland, and I was based at Corindi, Tamworth and Kempsey, and I've spent 25 years working in natural resource management, primarily on soil erosion and also river rehabilitation. So the first round the room discussion at the start of the day, there's obviously a lot of people who mentioned riparian zones and erosion. I'm also here all day, so I'm happy to talk about that sort of stuff because assessment, design and implementation of works to address those issues is something I've worked a lot in the last 20 or so years. I've had around about 6 years up in the NT and returned back, now have a small property at Bellingen, run a few beef cattle there, so I've been back for a couple of years. So a lot of these stuff we've been talking about today has been just great for myself personally about how I implement things on my own property. But there's just a real commonality, I think, in all the talks that we're seeing, which is really good. You've had obviously a catastrophic event and on top of a drought, and you've got to understand, I think, or just recognise that you've had a massive impact to the soil, to the vegetation, to your river systems, and it's going to take a while before you'll see an improvement from that. Arguably, we're still seeing an effect of original settlement, whitefella settlement in these landscapes to those river systems. So we need to expect that we're going to have a delayed sort of or a little bit of time before we see some improvements, but that's not to say you're not going to see improvement. You're already seeing some improvements now, so it's just about recognising that it is a longer term thing we need to be focusing on. And I thought Lee's talk then on soil was excellent, because what it talked about is, or what Lee said, you need to look at plants, soil, microbes, the soil organisms as one thing, because you need that functionality of all that to help get our landscapes restored and also our productivity back in our properties and our landscapes, which will then have obviously beneficial impacts on water quality. So soil erosion is all part of that same thing. So I think that really sets I guess the tone of the day is actually how we manage that, how we get the energy from the sun into plants to feed the microbes, to get a healthy soil biology, because it's going to improve your mineral cycle and your water cycle and have a lot of benefits right through the catchment. So that's the big picture stuff, I guess. That's how we then take those tools and implement them in our own individual situations to get that sort of benefit. It's a challenge for sure, but there's some really good ways of achieving that. So this talk will just touch on understanding a little bit about your soil type, how you then look at techniques of capturing and slowing water on your property, and some of the erosion control strategies you can use in emergency situations, and then longer term strategies as well. Next. So soil colour is probably something that you first really notice when you dig a hole or you go past a road cutting or something like that. You might see soil colour, and that can give you a little bit of insight into the characteristics and maybe the behaviour of the soil. So your black soils tend to be fairly high in organic or clay colloids, and they tend to be less erodible but have that high shrink swell capacity. So, when you hear people talk about reactive clays and things like that. So black soil, if you've ever been out west to Liverpool Plains area, sort of southwest of Tamworth, west of Corindi, that's all black soil country. It's all basalt derived soils. Some of those top soils or some of those upper profile soils are incredibly deep, utilised for cropping, but you'll get gill guys, or the swelling and the shrinking of those. You'll get big cracks in dry periods, and then as it wets up, you'll sort of get this gill guy formation in those soils. And you put a fence line in, it might be straight on one day, and then you go back a year later and the fence posts are everywhere just because of the reactive nature of that clay. Red soils tend to be strongly aggregated, but that just means they form when they form their PEDs or their aggregates, there's quite a bit of airspace in between them. So as a result of that, they're generally well drained. Some of the Dorigo soils would be a good example of the red soils, and they're also less erodible naturally. Yellow soils will tend to indicate sort of more poorly drained soil, and you may find that you're getting a high proportion of sodium in the soil, which makes it more prone to erosion because the bonds that the soil forms between itself and the clays isn't as strong. So when you add water, it readily sort of disperses or falls apart. Grey soils will tend to indicate quite waterlogged type soils. They also potentially could be erodible. And mottled soils is when you get that sort of coloration in your soil. It might be a purpley grey looking type soil. I often see that in, you might have a watercourse that's been like on a floodplain that's been sort of incised, and you might see some mottled soil, and they'll also be more erodible. So generally, this is really general though, like the black and red soils are going to be your less erodible soils. Your yellows, greys and mottled soils will tend to be more erodible.
What are the geological histories of those soils?
Yeah, so all your soil colour comes from the minerals in the parent rock, essentially. So what they've derived from. So, you know, like your black soils are going to tend to be more basaltic type soils. So, and then as you get into the different colours, the yellow soils, like I was saying, they tend to be higher in sodium. They might be siltstones or mudstone derived, but yeah, your soil is inherently based on your geology of your parent rock, because it's all part of the weathering process that produces your soil. Floodplain soils is probably a little bit different, where you might get vast areas of deposition from upland areas. So yeah, so I think it's always good to, if you've got access to looking at the geology of the area or a geological map, you'll find a probably pretty strong correlation to your soil maps. There's some pretty good resources around these days. That's another thing that blows me away these days, is the amount of information that's available. Like, you just look out here and then you've got webinars that are running and you've got websites of all this information. It actually can be quite overwhelming, I find. But what you need to keep in mind is there's not really one solution to your problem. There might be a number. So you've got to take the information that's probably more applicable to your own situation to come up with some strategies and work that into your farm plan, as Albert was pointing out in his talk. So yeah. So what's in soil? Once again, this is fairly general. So your soil's made up of your mineral particles. You've got some air, you've got water, and that would obviously depend on the season as to how big a proportion that would be. Your air would depend on how compacted the soil is. Then you've got organisms, roots, humus and organic matter making up that 5%, which ideally you want that higher than that, I would suspect. So that's a fairly old slide, that one, but I think you want to be trying to maximise your organic matter through whatever practices you're applying on your soil. But that, once again, that's a very general graph to show you proportions of your soil. Now, this slide is to put in perspective the different size fractions within a soil particle. So the combination generally of your clays, sands and silts is what they use to define soil texture. So you might have heard the term of I've got a sandy clay, or I've got a clay loam or a silty sand. They're texture descriptions, and they're based on the relative proportions of those size fragments. So that's where that comes from. So what really jumps out from there is, if you look at the size of a clay particle right down the bottom, it's just like a pencil prick in comparison to a coarse sand. So the clays are tiny, but they also are quite significant in what happens when soil gets washed away, is because clays are a charged particle and they can have nutrients attached to them, and herbicides, pesticides can attach to them as well. So when you're losing your clays through erosion, that's when you're washing in nutrients and potentially other pesticides, herbicides, etc. So just a few soil profile photos here of that's it, your darker type soils, your black soils, red soils. You can sort of almost see from that it looks like that would absorb water like a sponge, just the way that soil structure is. It's got that aggregated nature. And if you're building dams out of material like that, sometimes you'll actually have to add a product to help them disperse, to seal the dam, because you can build a dam wall out of soils like that, and then you'll find, oh, my dam leaks, you know, because there's so many pores within that soil type. So it might be high in clay, but it's a type of clay that tends to aggregate and doesn't actually disperse enough to form a seal. So here's some of your grey. That slide on the right is a mottling. That's the mottled look of the soil. So you're prone to dispersion and slaking, which is if you put grab a piece of soil and just put in water and watch how it behaves. If it just sort of collapses, if that soil particle just falls down and collapses and the water remains relatively clear, this is without shaking it, just drop it in, that would indicate that that's a slaking soil. Whereas if you drop it in and it just all dissolves and the water becomes really cloudy, that's a dispersible soil. And it's just a simple test you can do. Just grab a bit of soil and put it in a cup of water or something. And you might have slaking and dispersion occurring as well. But you can do a scientific test called the Emersons Aggregate test, and that's what they would do to determine how erodible your soil is through that. A couple more photos of erosion and gullies and erodible soils. Are you right? So in terms of managing erosion, you can actually quantify how much erosion occurs off a site. There's been an equation developed by some scientists who worked out around Gunnedah years ago, and it's actually been adopted worldwide. It's called the universal soil loss equation. And so it's essentially a multiplier of the rainfall erosivity, the length and slope, so the slope length as well as the degree of the slope, the inherent nature of the soil itself, its inherent nature or erodibility, I guess. Then you've got your what they call conservation practice. So is it a compacted site or has it been managed to promote infiltration? And then you've got probably what I think is one of the most important part of that equation is the soil cover. So soil cover, if you can actually maintain a good soil cover, you're going to dramatically reduce the potential for erosion. I know it's a bit of a no-brainer, but you can quantify all that, and like when I work on highway projects and design sediment basins and things like that, that's what we base the size of the basin on, is the potential for soil and how much erosion could occur off that site. So soil cover is also something you have some control over to a certain degree. Obviously with a drought and fire situations, that soil cover has essentially got back to zero, like you guys were pointing out before. But cover is sort of the main thing you need to try to focus on as best you can. If you can maintain cover, and I always used to talk about this 70% cover, I'd say that's a minimum. If you can, minimum 70%, look, you want 90 or 100%. How do you measure it? You can get like a quadrat, just a square. I'd make one out of PVC, just electric conduit PVC, and just throw it on the ground, and you can actually estimate what proportion of bare ground is in there and what proportion of cover. So the cover can be in terms of, it might be plant growth, it can be leaves, it can be sticks, it can be rocks. That's cover, that's soil cover, that's protecting that soil. There's also, look, so the more cover you've got, obviously you're going to slow the water flow off your place, you're going to promote infiltration, and you're going to reduce the potential for erosion. Dams will also help slow up water. They're going to be more expensive. You can use them obviously within your landscape to suit your grazing enterprise, whatever other enterprise you have. You may be able to incorporate them in, I think what Andrew will probably touch on, in keyline farming in Yeoman's keyline farming and how you actually move water across your landscape and store and have it available to release to other areas. Gully control structures, so they're structures that you might build in an eroding gully to help prevent that erosion, ongoing erosion of the gully. That'll help slow up flow and reduce erosion. Contour banks, we'll get to some photos of them in a minute. We actually might flick the next slide, please, Jess. So there's just a typical dam in a undulating setting. Go to the next photo. So contour banks been like widely used west of the Divide in these cropping locations. So what the contour bank does is, when I was talking about the length and slope of a particular landscape, what they're doing is breaking up the length of the slope. So instead of water running directly down the hill, you're trying to intercept it and run it down and increase its length of flow and reduce the erosive potential of that runoff. For grazing enterprises, I think there's a much better way of achieving infiltration into your soil by looking at how you manage your pastures. So these structures are really about channeling water, and it's almost, you're sort of missing an opportunity in some ways of actually getting it to infiltrate into your soil, because where you want the water is in your soil profile. You don't necessarily want it sheeting off your land. You want it within your soil profile. These cropping areas where you're running bare fallows, which you can potentially get a lot of erosion off there. Haven't got the potential to use as much water in that soil profile. Once it's full, the water's going to run off. We want active plant growth as much as possible, I think, to try to use the water there, store your water in your soil profile, then allow it to percolate through the groundwater into our river system, so we get that sustained flow through our rivers rather than that short, sharp burst of rainfall, surface runoff into our rivers, damage, and then it goes dry again. We want that sustained flow if possible, and by promoting infiltration into your soil and storage of water in your soil profile, that's going to help achieve that. So there's other ways of, if you've got small areas in your on your property where you want to try to promote or store a bit of moisture, you can do some little buns around areas just to try to temporarily store water to help plant growth. We'll go on to some emergency situations. We'll look at a few photos here. Next thing, Jess. So, there's invasive ways you can get in there and use rock structures, geotextile, machinery. Obviously, we're starting to talk about a lot of dollars, and what you're really dealing with is not really the cause of the issue. You're trying to deal with a symptom a little bit. So often these sort of works are not going to be that suitable for individual landholders to implement, but there's ways of actually implementing things to slow flows, like using debris you might have if there's anything left. With logs, you can use, well, that's actually a highway site before they started doing the earthworks, is they surface mulched the whole lot just to protect the soil from erosion until they were ready to start working in there. There's products like coir logs, but you can use like timber debris or brush debris to try to promote infiltration and roughness and slow flows across your landscape. That's mulch as a bund around an eroded a bare area to trap anything that runs off from that. So the mulch will act as a filter to let water slowly infiltrate through that. There's jute mesh that's available that you can buy commercially, biodegradable. You can topsoil underneath that, seed underneath that, put the jute on to give that some initial protection, and the grass grows up through it, and over 6 to 12 months that jute will break down, and then hopefully you've got a good vegetation cover that's coming up through there. So long-term strategies, it gets back to your farm planning. It's really about thinking about, well, I would start that by saying, look at your soil management and how you're managing for plant growth and promoting infiltration. Then you might look at your structures, so dams and gully control structures, but think about where you're going to put a dam so it has the most benefit to what your enterprise is. It might just be scenic, it might be part of your property because you like the look of it, it's a wildlife refuge, or it might be something you want to reticulate from to water your whole property for your stock. So you might want that dam as high up the catchment as you can practically get it, so you've got that opportunity to gravity feed to other paddocks. Fencing's important. Like Albert put his grand plan up for his property. Fencing, so you can control your grazing pressure. Use cattle to actually promote vegetation growth. You know, through you might need some impact in some area and some dung and urine to get the nutrients in there. Get them in there, just a hot wire around them. Get that animal activity. Get them out of there, and then you might even throw some seed in amongst it when they're in there, just to trample it in, so they don't have to get the tractor out, and then see what happens, see how it responds. I can certainly vouch for using single wires and getting cattle quiet and using them to move around the paddocks and do some of your work for you. Good ground cover, yep, 70% plus, I'd say, and in your flow line, so creeks and gullies, it's the same principle. It's vegetation that's going to help hold the thing together. But I know the challenge is we've gone from good vegetation, we've had this fire that's ripped through here, destroyed all the vegetation. How do we then get it back? And it's using bits and pieces of these other techniques that might be appropriate to you. But I'd look at things like coming into this time of year, it might be a matter of doing some hand seeding of some sterile sort of annual plants like Japanese millet or something like that, just to try to get some cover and try to get the promotion of your fungi and that in your soil, and then hopefully start a snowball effect of getting some more species established. Don't rush out and just whack all your weeds, because as Lee pointed out, we don't want bare soil, particularly in those really sensitive areas. I think you're going to have your declared noxious species where you probably do need to be focusing a little bit of them. I'm sure Anthony will be talking about that next bit. But any cover is better than none. I'd sort of say, I guess I'm a bit guarded when I say that, but that's to unless there's some noxious new species that are coming into your system, then that might be a different situation.